Greetings to the presentation on the reciprocal system of theory by Dewey B. Larson. The name of the presentation is A Universe of Motion, of which now we shall be checking out the subdivision three-dimensional motion. I am Gopi Krishna and I'll be guiding you through this presentation. So let's begin. First of all, let's have a look at the origin of this idea. From the first postulate, we have the phrase existing in three dimensions. What dimensions are we talking about? And what is meant by the dimension of a motion? And how is it different from our conventional view of the physical universe? These are the things which we'll be checking out. So, let's look at the first. The definition. The definition of dimension in Latin is dimentio, or to measure. The number of independent variables required to specify a quantity completely is called a dimension. Hence, these dimensions, or the variables used to represent them, are completely independent of each other. And the dimensions of motion which we speak about in this presentation means the three ratios or the three speeds, independent speeds, which determine a motion completely. Now let's use the definition. Our usual idea of dimensions is mostly regarding the nature of space. We apply the definition to get the three independent and orthogonal values. For example, take the first row to your left, the second to your right, and come to the third floor. Gives all the three dimensions: width, breadth, and height. To that, we usually add a fourth dimension, be there at 11 AM sharp, which is time. Now let's see how it relates to our universe. Our conventional 3D reference systems. Let us have a look at what we usually measure in our day-to-day life. This is called the conventional reference system or the coordinate spatial reference system. This is because we measure space as coordinate space, that is, having three independent dimensions x, y, and z, whereas we use clock time or a scalar progression of time which is measured on a clock for our reference in case of time. The conventional system has the following properties. Space can be represented by a vector. Time can be represented by a scalar, and it is measured separately. The ratio of space to time is hence a speed with a direction, that is, a velocity. So, motion is measured as a vector in our conventional reference system. However, in the reciprocal system, the three dimensions are of scalar speeds. So, we have speed 1, speed 2, speed 3, being the three independent speeds which totally determine a motion. So, how do we go about representing this? Now what? Now we determine how much we can measure and how. Note that our reference frame measures only vectorial motion, and due to the nature of scalar motion, three scalar speeds cannot be represented as independent motions. So, what can we measure? Let's look at this. The three scalar speeds are shown by the orange arrows, and that is the scalar range. This we represent using coordinate space and clock time, which is our conventional reference system. This measurement comes in the coordinate range. representation of motion. The scalar range is the full range of motions which occur in the universe. We have not yet coupled our reference system to measure them. This is what is possible according to our theory. And the coordinate range is what we ultimately measure. The conventional reference system can only represent any one scalar speed completely. And the other two speeds, what happens to them? The other two scalar dimensions can have no direct representation on this conventional reference system, but they do have an indirect representation. And what does that mean? That means they can modify the magnitudes of motions in the conventional reference system. In other words, they cannot be represented as we normally represent motion, but they can be represented only in a change of magnitude of what we already measure. So the story so far is, we have 3 dimensions of coordinate space, we have 3 dimensions of scalar speed in the reciprocal system. This gives rise to a question: why not use 3 dimensions of coordinate time and scalar space? Or the question is, can time be 3D? Because if this is possible, where space has 3 dimensions, 4 meter, 5 meter and 6 meter, and time can be represented by one scalar 8 seconds, then so is this, where time is represented in 3 independent dimensions, 4 seconds, 5 seconds, 6 seconds, and space gives the scalar 8 meter measurement. So the answer to the question is, oh yes. Scalar or clock space. Space and time are 2 aspects of motion, as we have seen. This definition does not preclude either one of them from having properties similar to the other. Hence, logically, we can have coordinate time and scalar space. Scalar or clock space. Scalar space is also a uniform scalar progression. That is, it has no vectorial aspects, no direction and only a magnitude. It can hence be measured in a way similar to clock time, because we measure clock time as only a scalar progression. This is what gives the name to this kind of space as clock space. The reference systems. The 3D spatial reference system is what we normally use, which consists of clock time and coordinate space. And we now have another option of using 3D temporal reference system, which has coordinate time coupled with clock space. Coordinate space can be represented as follows: x, y and z, and clock time has just a scalar magnitude. In other words, motion can be represented by Sx, Sy, Sz and t. And similarly, in coordinate time, we can represent motion as S, Tx, Ty and Tz. The subscripts x, y and z show the 3 independent dimensions. So this is the complete representation of the scalar motion. There are the 3 scalar speeds as usual, and only one of them can be represented, and it can be represented in either of the 2 ways. One is coordinate space and clock time, and the other is coordinate time and clock space. So we now have the take-home ideas. There are 3 scalar speeds. Representation of only one speed is possible, and we have 2 kinds of reference systems. One, coordinate space and clock time, and the other one, coordinate time and clock space. We can use either one of these reference systems or both of them. Thank you. To identify the units of motion, we have the next presentation, quantization.